So what I'd like you to think about is, especially those word problems we did where we had the eagle on top of a cliff and all that stuff. Every triangle that we have had to solve in this class has been a right triangle. And when you have right triangles, you are allowed to use things like SOHCAHTOA. But SOHCAHTOA can only be used in right triangles. How do I know that? How do I know that? What's that H stand for? Hypotenuse. And what kind of triangles have a hypotenuse? Right triangles. So, take a look at your notes. We are on section 5.5. It says solve triangle CHS. Now, when we solve a triangle, boys and girls, what we are doing is finding all of the missing parts. So in this problem, we need angle H, we need side H, and we need side C. Those are the missing parts. So I think the angle H is pretty easy. What is angle H? 75. Because the angles of a triangle have to add up to 180, right? Now, do you see why SOHCAHTOA is not going to work in this problem? So there's no more SOHCAHTOA. Instead, we're going to use something called the law of sines. It is very, very easy to use. It hinges on, however, you having information like this. This is what I call a pair. I have angle S and I have side S. In order to use the law of sines, you have to have one pair, okay? If you don't, we'll use the law of cosines. But if we have a pair, we're going to use the law of sines. And this law of sines simply says sine A over A equals sine B over B equals sine C over C. Everybody loves the law of sines. It is so easy. Obviously, my letters are different, but the idea is the same. So start with your pair. Your pair is sine 45 over 3.7. So sine 45 over 3.7. Now, set that equal to something. It doesn't matter which one, because you're going to have to do both. Just pick one. Want to do sine 60 over C. When I'm done with that one, I'll do the other one, starting with my sine 45 over 3.7, and it will be sine 75 over H. Then I get out my cross multiply. Everybody keeping up? So C sine 45 equals 3.7 sine 60, just cross multiply. And then if I want C by itself, I'm going to divide by sine 45. So C will equal whatever that is right there. Now make sure your calculator's in degrees. These angle measurements are in degrees. So 3.7 sine 60. When you type in 3.7 sine 60, be sure you close that parentheses. It's going to put a parentheses, be sure you close it, and then divide it by sine 45. Did you get 4.53? So side C is 4.53. All right, and then we repeat. Repeat the process. So H sine 45 equals 3.7 sine 75. take 3.7 sine 75, close parentheses, and then divided by sine 45. Did you get 5.05? And voila, the triangle is solved. Wow. Seems easy, doesn't it? Let's try the next one. The next one is exactly the same, except I didn't draw the picture. You have to draw your own. So here's C and H and S. Where you put it doesn't matter. Just C and H and S. So C is 40, H is 30, and side H is 10.8. See this right here, guys? That makes your heart sing, because that means you're going to use the law of sines. When you have that kind of thing right there, that's the law of sines. Okay, do I know angle S? Well, I do. Angle S will be 110. All right, so set up my law of sines. What's it gonna say? Sine 30 over 10.8. Absolutely, that's how we're starting with the pair. And what do you want to set it equal to? Sine 110 over S. We'll solve that. And then we also have to set up the other one. You repeat, I do it twice to find the other side. Go back to sine 30 over 10.8. This time it's going to be sine 40 over C. Okay, so we cross multiply and divide. All right, what'd you come up with? Anybody have an S and a C? S is?
20.3.
What?
20.3.
20.3, that's a big number. But it makes sense, because isn't that a big angle? Big angle's gonna have a big side. Okay, this one better be small then. What's this one? What? 13? Oh, it can be. 13 point what? 88? Did somebody match that? I did not type this in. No?
Right here.
20.3 is what I got for that one. And 13.88 is what I got for that one. So you guys have said that he was wrong, you're wrong. Those are correct. All right, one more. C is 53, H is 48, and side S is 19.1. It is really important that when you draw your picture and start labeling things, that you have it labeled correctly. What I mean is, I don't care where the C, H, and S are, but if that's angle S, then this has to be side S. And this is side C, and this is side H. Now, sometimes kids look at this and get a little panicky, because I told you with of signs, we gotta have a pair. We really do have a pair because can't we figure out this angle real easily?
79,
So how big is it?
79.
79, is that right?
Yes.
Yeah.
And then there's your pair. So let's go, sine 79 over 19.1 equals, order doesn't matter, sine 48 over h. Sine 79 over 19.1 equals sine 53 over c. Remember, anytime you're doing this cross multiplication, close the parentheses after any angle that you type in. So 19.1 sine 48, close parentheses, divided by sine 79. I got 14.46 and 15.54. I'll wait for confirmation
Yeah,
from
you're
you.
right.
All right, when you came in today, I told some of you the law of signs is so easy. Would you agree?
Yeah, I agree.
Very easy. There is one little tricky component to the law of signs. I'm going to show you what that tricky component is. Let's look at the next few problems. The next few problems say how many triangles are possible, solve them. So let's look at problem A. Here's angle B is 82, side B is 17, side C is 50. Now again, it does not matter where you put the A, B, and C, but 17 has to be across from the 82. Is that, or do I have a pair?
Yeah.
I do. And anytime you have a pair, you can set up the law of sines, okay? So what's it gonna look like this time? Sine 82 over 17 equals,
Sine X.
you see, just keep my
RC,
letters
yeah.
consistent, but yeah, sine C over 15. So I'm gonna cross multiply and divide again, so 15 sine 82 equals 17 sine C. Now, what's my variable? I'm gonna divide now. What am I gonna divide by? 17. Because my variable is sine C. So sine C equals 15 sine 82 divided by 17. Now I want you to think about this for a second. You know what to do. If you just type this in, right here, this fraction, you're going to get a decimal point, whatever. Is that the answer to the question? No. The answer to the question is the angle. How big is that angle? Well, what do I have to type in my calculator to get an angle? Second sign. So C is going to be second sign that fraction. So the fraction itself is not the answer. To get the answer, you have to second sign that fraction. So second sign, 15 sine 82, close parentheses, divided by 17. I got basically 60.9. Anybody else get that? Would someone nod? Okay. Now that I know that's 60.9, can I find angle A? Alright. 37.1. And now that I know angle A, can I find side A?
Yeah.
Always go back to the original pair. So sine 82 over 17 equals sine 37.1 over A. I got 10.26. How does that sound? All right, everybody good? Okay, so the directions on this problem were different though. The directions on this problem started out with how many triangles are possible. What does that mean? Well, first of all, this problem, while the equation was basically the same, what was different about what I was doing here? In step one, I was actually finding an angle, okay? So, use law of sines to find angle equals caution. Because if you look at the given, the original given, I was given this 82, I was given this 15, and I was given this 17. That's what I was given. In geometry class, we called that angle, side, side. Angle, side, side. And what do you know about angle, side, side?
It doesn't exist.
Can't do it. And your geometry teacher probably said, don't use angle, side, side because it's a bad word. Remember, you used side, 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 angle. You used all those combinations and they were all good, but not this one. This combination, angle, side, side, you will know, if you miss it in the setup, you will know it the minute you do this. The minute you set up your law of sines and it looks like this, you're gonna have a caution. Because there could potentially be a second triangle. This is called the ambiguous case because we don't know if we have one or two. If it's side, 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 angle, side, angle, all those, it's one, done. No ambiguity. This is the one problem, okay? All right, so you must check for the second triangle. Here's how you very easily can check for the second triangle. Here's the given. That's the given right there. When you second sign, there are potentially two answers to that question. One of them was 60.9. The other one will always be 180 minus the original. So in this problem, that second angle, if there is one, is 180 minus 60.9, which is 119.1. When you do this, you must check for a second triangle. To check for the second one, it's real easy. Do 180 minus your first angle. Now, stand back and look at that for a minute. Does anything about that bother anybody? It's already over 180. So how many triangles are possible? Just one. The second one did not work out. If this had been like a 42, could that have worked?
Yeah.
And that would have been another triangle that would have been part of my answer.
And then do you have to check for another one, or you
No,
just
it's one, it's either 0, 1, or 2.
Okay.
0, 1, or 2. Those are the only options.
Once you are
checking, and do you have to like check the sides and the angles?
No.
Or?
Oh, well, you can, that's another way of looking at it, yes. So you're saying, this was 82, you're saying there's no way that 82 can be across from 17 and 119 can be across from 50, absolutely. That's another way of checking. I always just check to make sure these are under 180. You can also look at that. Oh, sure, yeah. All right, let's try the next one. All right, so here's the triangle. A is 73, A is 24, B is 28. So you see this right here, and you immediately think law of sines. Okay. You should think that, that's right. But then you notice that, oh shoot, I'm using the law of sines to find an angle. Now, that's doable, it's perfectly okay, but that means I have to check for a potential second triangle. All right, well, let's go ahead and get started on this one first. So 24 sine B equals 28 sine 73. So what am I going to type into my calculator to get angle B? Second sine, that fraction. 28 sine 73 over 24. Second sine, 28 sine 73, close parentheses, divided by 24. Did you get an error?
Yeah.
Let's try it again. Second sine, 28 sine 73, close parentheses, divided by 24. That means there's no triangles possible. Remember, when it says how many triangles are possible, it could be 0, it could be 1, or it could be 2. So our first example was a 1. This one is a 0. When that calculator says error, that means this is not possible. Okay, done. Last one. So C is 32, C is 10, A is 18. Come on, guys, we gotta get this done. All right, you recognize your law of sines right here? So sine 32 over 10 equals sine A over 18. And the minute I write that, I go on high alert. Caution, caution, there might be another triangle. Well, let's see if this even works out. So sine A is going to equal 18 sine 32 over 10. We're going to go through it again. Let's just see if we can solve this one. Second sine 18 sine 32 close parentheses divided by 10. Did you get an answer?
Yes.
Okay. So 72.53 is my first answer. Now, let's go ahead and finish solving this one, and then we'll worry about if there is another one to solve. But let's finish this one. Once you know or angle C and angle A, then we can find B. Would you agree?
Yes.
$75.47. Now, can we find side B? That's easy. So go back to sine 32 over 10. And sine 75.47. go ahead and work this out for me. Tell me what you get. That's what I got. Everybody get 18.27? Okay, so the directions said how many triangles are possible, solve them. So we know we have at least one, and we have solved it. Now, if there is another one, it obviously is gonna have exactly the same given as the original. But instead of angle A being 72.53, it will be 180 minus 72.53. It's always what we call the supplement. 180 minus 72.53. 107.47. Is that triangle possible?
Yeah.
So now you get to solve that one, okay?
You just saw the whole thing?
Solve the whole thing, yeah? So, that's easy though, look, you know B has to be 40.53. And then you're gonna find that side B, sine 32 over 10 equals sine 40.53 over B. All right, what'd you come up with? 12.26? Okay, so we're gonna do one more problem and we'll be done, but here's the deal. How do you know, if you just got a bunch of triangles to solve, if this is A equals B equals C equals all that stuff, how do you know that you have to worry about this? Because it won't be clued, these directions had a clue, how many triangles are possible? They're not gonna be clued in. How do you know you have to worry about this?
We have to use law of science to find an angle.
Exactly. So if your first step looks like this right here, then you know you might have a second triangle. And we've gone through an example of each kind, so we're good on all that? Okay. All right, so now we're ready for number 3. Observers see a higher balloon, angles of elevation shown in the figure, find the altitude of the balloon. Is this a law of sines problem? Can I do the law of sines on this problem?
Yeah.
I can, because how big is this angle?
115.
Is it 115, is that right?
Yes.
Okay. So right there's your pair. Now we aren't solving this whole triangle, so we're gonna just pick one side or the other. Which side do you wanna pick? Oh, let's see, these are labeled A, B. So we're gonna find side A? All right, so sine 115 over 2.32 equals sine 28 over A. Does that make sense to everybody? Okay, let's find A. I got 1.20, but that might be wrong, is that right?
I got that.
Mileage.
Okay, now wait a second. Okay, that's fine, and I could do the same thing and find this one, right? But neither of those are the answer. Because what is the question asking me
The
for?
height
The height.
of the middle.
So that would be this right here, right? Isn't that what I'm looking for?
Yeah.
Okay, now,
1/2 base. That means.
1/2 base times height is a thing, but it's area over area. All right, now, when I drop that altitude down, I know nothing about either one of these angles.
Yeah, you
This triangle is not isosceles. However, is this now a right triangle?
Yeah.
Can I say the sine of 37 equals x over 1.20? Because sine is opposite over hypotenuse.
Yeah.
Could I also do sine 90 over 1.20 equals sine 37 over x? Could I do that right here in this triangle?
Yeah.
Whichever flips your switch. It's a right triangle, you can SOHCAHTOA. Law of sines works all the time, even in a right triangle. That is gonna give us our answer. So 1.20 sine 37, the height of that balloon is 0.72, and what's the unit? Miles. So it's 0.72 miles high. We'll finish this up next time. Do not forget math week tomorrow. And thanks again for your 5-day contributions. You guys were so good. If you need a cookie for the road, you can take a cookie for the road.